Hello, and welcome back to AI Ed from Bits to Breakthroughs. I'm your host, Zoey 1.0, one of the AI-generated avatars here at newbits.ai. I'm excited to have you join me again for our AI Basics, the Fundamentals series. In our last episode, we introduced the series and set the stage for exploring the fascinating world of artificial intelligence. Today, in our second episode, we'll take a journey through the evolution of AI. We'll explore its inception, key milestones, and the important individuals and ideas that help shape it into what it is today. Understanding AI's history provides crucial context for where we are now and where AI might be heading. So let's start at the beginning. The origins of modern artificial intelligence can be traced back to the 1930s. In 1936, British mathematician Alan Turing introduced the concept of a universal machine, what we now refer to as the Turing Machine. This theoretical device could compute any computable function given the right algorithm. Turing's work laid the foundation for the theory of computation, and eventually the idea that machines could be designed to simulate any form of intelligence. In 1950, Turing took his ideas further with his paper, Computing Machinery and Intelligence, where he posed the famous question, "Can machines think?" In this paper, he introduced the Turing Test, which is designed to evaluate whether a machine's behavior can be indistinguishable from that of a human. The Turing Test remains a key concept in AI even today. As we move into the 1950s, another important figure, Norbert Wiener, made significant contributions with his work on cybernetics, which studied communication and control in animals and machines. Wiener's ideas about feedback systems in machines had a major influence on the development of artificial intelligence and robotics. But the biggest milestone of the 1950s occurred in 1956 when John McCarthy, a computer scientist at Dartmouth College, organized what is now considered the first formal meeting on artificial intelligence, the Dartmouth Conference. It was here that McCarthy coined the term artificial intelligence. His vision was to create machines that could perform tasks that would require intelligence if done by humans. McCarthy believed that machines could simulate human intelligence, and his proposal for the Dartmouth Conference was ambitious: to investigate every aspect of learning or any other feature of intelligence that can in principle be so precisely described that a machine can be made to simulate it. McCarthy's contributions didn't stop there. He went on to invent Lisp, a programming language specifically designed for AI development. Lisp would become the dominant language for AI research for decades, and it remains influential today. McCarthy's work laid the foundations for AI research, and his ideas inspired a generation of scientists to pursue the goal of creating intelligent machines. At the Dartmouth Conference, McCarthy was joined by other influential figures such as Marvin Minsky, Claude Shannon, and Nathaniel Rochester. Together, they pioneered the early days of AI, focusing on logic, symbolic reasoning, and problem solving. Following the conference, AI research took off, and early systems like Logic Theorist, developed by Alan Newell and Herbert A. Simon, demonstrated that machines could prove mathematical theorems. This was an important breakthrough because it showed that machines could engage in symbolic reasoning, which was considered a hallmark of human intelligence. However, by the 1970s, AI faced a major setback. Early systems were highly specialized and couldn't adapt well to more general tasks. This led to the first AI winter, a period of reduced interest and funding in AI research. Symbolic AI, the approach that had dominated the early years, was limited by its reliance on rules and logic that could only be applied in controlled environments. These systems failed when confronted with the complexities of the real world. In response, many researchers shifted their focus toward machine learning and other approaches that allowed systems to learn from data. But the lack of computing power and available data limited their success at this stage. In the 1980s, AI saw a revival with the development of expert systems. These systems attempted to emulate the decision-making processes of human experts by applying predefined rules. One famous example was Dendrol, an expert system developed by Edward Feigenbaum and Joshua Lederberg at Stanford University to help chemists identify molecular structures. Another significant expert system, Mycin, was developed in the early 1970s by Edward Shortliff as part of his PhD work at Stanford University under the guidance of Bruce Buchanan, Stanley N. Cohen, and Joshua Lederberg. Mycin was designed to help doctors diagnose bacterial infections and recommend treatments based on medical data. It was an important demonstration of how AI could be applied in real-world healthcare scenarios, showing that machines could assist in expert decision-making. Although Mycin was never fully deployed due to concerns over liability, its development was a key milestone in AI's application to medicine. By the late 1980s, the limitations of expert systems became apparent. They were expensive to develop, difficult to maintain, and could only operate effectively in narrow domains. As a result, AI entered another period of decline, often referred to as the second AI winter. But the 1990s saw the rise of machine learning, which marked a significant shift from rule-based systems to systems that could learn from data. The availability of large data sets, combined with improved computational power, allowed machine learning algorithms to flourish. A key technology that gained prominence during this time was the neural network. Neural networks are computational models designed to mimic the way the human brain processes information. Just like the brain is made up of interconnected neurons, a neural network consists of layers of nodes, or neurons, that are connected to one another. These networks process information by passing it through multiple layers, each performing calculations and transformations on the data. In essence, neural networks learn by adjusting the weights between nodes based on the data they are trained on, allowing the system to improve its accuracy over time. Early versions of neural networks existed before this period, but it was the development of the backpropagation algorithm, pioneered by Geoffrey Hinton, David Rumelhart, and others, that made them practical for solving real-world problems. As we moved further into the 1990s, one of the most iconic breakthroughs in AI came in 1997 with IBM's Deep Blue. Deep Blue became the first computer system to defeat a reigning world chess champion, Garry Kasparov, in a highly publicized match. This victory demonstrated that machines could excel in complex strategic thinking, proving that AI had the capability to handle tasks previously considered exclusive to human intelligence. Deep Blue's success was a pivotal moment for AI, marking a major milestone in its evolution. The 2000s saw the continued growth of AI, but it was in the 2010s that AI truly accelerated, thanks to the rise of deep learning. Deep learning is a subset of machine learning that uses multi-layered neural networks to model complex patterns in data. A major breakthrough came in 2012 when Geoffrey Hinton and his team at the University of Toronto achieved record-breaking results in image recognition using deep neural networks. This breakthrough revitalized AI research and set the stage for widespread applications of AI in various industries. In 2016, AI reached another iconic milestone with DeepMind's AlphaGo. AlphaGo, a deep learning system, defeated world champion Go player Lee Sedol in a series of matches. Go is a highly complex board game, significantly more challenging than chess due to the vast number of possible moves. AlphaGo's victory demonstrated the remarkable progress of AI and reinforced the power of deep learning and reinforcement learning systems. Also shaping the AI landscape is OpenAI, founded in 2015. OpenAI's mission is to ensure that artificial general intelligence, AGI, benefits all of humanity. OpenAI has made significant breakthroughs in natural language processing, especially with the development of GPT, generative pre-trained transformer models. GPT-3, released in 2020, was one of the most advanced AI language models of its time, capable of generating human-like text and performing tasks such as translation, summarization, and conversation. OpenAI's work has set new benchmarks for language models and expanded the boundaries of what AI systems can achieve, playing a key role in driving innovation in the AI space. Today, AI is all around us, from voice assistants like Siri and Alexa to self-driving cars, and even in healthcare, where AI systems help diagnose diseases and develop new treatments. At newbits.ai, we aim to make AI accessible by providing you with cutting-edge AI solutions, models, tools, and platforms that build upon decades of research. We encourage you to explore and experiment with these AI models, tools, and platforms by visiting our AI solutions page at newbits.ai. Join the conversation on our AI Hub and share your thoughts on AI's evolution. How do you think past breakthroughs will shape the future of AI? In our next episode, we'll dive into demystifying AI, understanding the basics, where we'll break down key concepts and terms used in AI today. Thank you for joining me on this journey through the history of AI in our AI Basics, the Fundamentals series. We look forward to continuing this exploration with you. Stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.